applications engineer at Intel, based out of the Hillsborough office in Oregon. Today, I'm going to be talking about Intel Resource Director, Intel RDT, as I'll be calling it. And specifically, there are some demo machines. If you have your laptop, you can SSH into it. There should be login cheat sheets, but if not, I guess you can pay attention. I'll go through it up here as well. All right, so if you guys, or specifically this talk is going to be about the new feature in Cascade Lake is Intel Memory Bandwidth Allocator, and I'll get into that. There's other features of Intel RDT. All right. So what is Intel RDT? So basically, as of now, you can basically partition your CPU, your memory, your storage, but with Intel RDT, it gives you the ability to partition your memory bandwidth, and that's a Cascade Lake feature, and also last level cache. And I believe that's on, you can do that on Broadwell and Cascade Lake as well. So I guess if you're a system administrator or if you work at a cloud service provider, this could be a feature you could upsell to your customers. So for essentially, if a customer has a high memory bandwidth workload, that could be a feature that you could use, I guess, to partition low and high priority memory bandwidth workloads. All right, so the features of Intel RDT are cache monitoring technology. So you'll be able to monitor your cache, your last level cache real time. Cache allocation technology that allows you to partition the last level cache based whatever your whim or your desire. This one I haven't worked with too much, but code and data prioritization. Also, you have memory bandwidth monitoring, so you can monitor in real time, and then also memory bandwidth allocation. And that's just reiterating memory or monitoring, cache monitoring technology, CMT. For this, an example, or all the examples, you could use to monitor noisy neighbors, and it's up to you if you want to mitigate the noisy neighbors as well. Here we go, cache allocation technology. Briefly stated that. Allocate cache to, so basically, depending, at the end of the day, you're going to have to profile your workload to see if the cache that you need, or if you're cache constrained, I guess, is causing the problem. In this, the code and data prioritization allows you to have your code to sit on cache so you can fetch your instructions faster. And memory bandwidth monitoring allows you to, as I said before, monitor bandwidth real time. And then here, the demonstration or the hands-on lab, it's a simple tutorial. Will give you an idea of how to use MBA and also how to use Intel RDT. So there we go. And just for reference, this is on Cascade Lake. This is they added a controller onto the CPU to handle allocation of memory bandwidth. And here's a diagram of that.
Is there a default that is normally set? That's used by most You change.
Oh, the default is that any application that's running is going to be able to have full 100% memory bandwidth. So it's, on you
If
after.
you want to do that, then you might.
Yeah, then you would monitor and then you would modify, yes.
And are there any guidelines for what kind of a workload, what MBA you do, what?
What do you mean by that?
Assume that the user doesn't know what to set.
Oh, I see what you're saying. You're wondering if there's some automatically.
Not automatically guidelines.
Oh.
This, but
No, it's all manual. I'm going to mention there's a tool called ARM Resource Monitoring Daemon, but the tutorial that I'm going to show you is manually. So it would be on you to monitor it yourself and adjust accordingly. Does that answer your question? All right, I'll share.
let's assume that someone is a user,
Yeah,
right? They're not a master user.
yeah, they have no privileges.
They
Yeah.
assume that, and then they want to change their locations, etc., different feature, 4 or 5 features that you mentioned. Is there a guideline saying for this kind of a work that you, application that you're running, you need to have this range of different
No, there is no guideline like that yet. But I feel like as this becomes adopted more, there will probably be more guidelines in the future. And the requirements for Intel RDT for the memory bandwidth allocation, or for actually all of them, CM cache monitoring technology, cache allocation technology, and memory monitoring technology, you'll need a Linux kernel of 4.10 or greater. And what that has baked into the kernel has a kernel interface, so you'll be able to talk to a virtual file system, so you can read and write essentially your config settings. And I guess I could email out the slides just because it has some useful links. And from there, I was going to do, just to show you guys Intel RDT memory bandwidth allocation in action. All right. Should be able to SSH into this. Is that better?
Yeah, much better. But can you
The lights above?
Yeah, I think they can adjust it. You should
thing does not doesn't have.
Yeah, I don't have control of the light setting. Okay. All right. So back to that. So let me bring up my cheat sheet. Should be somewhere. See if I still have it. All right. Hopefully this works. So first off, I guess you already saw that as Cascade Lake. Let me clear this. So to get access to be able to configure Intel RDT, you'll mount the virtual file system. Control. All right, so if we CD into that, so basically, this is the root of it, and it will tell you basically information of how you can partition this system, what CPUs belong to this class of service. What's the schemata? The schemata means essentially how much of the LLC it's using, and also a percentage-wise of the, so if I do a cat of schemata, it will tell me that any task or CPU in the root is going to have 100% of the memory bandwidth, and surprised it doesn't say anything about the LLC. But if it, oh, that's another thing. I only have it set up for MBA, but if I should have also had I have to turn on a kernel option. So to do that, if you do, what is it? Let's see, default. Grub. So if you can see, where is it? Well, pretty positive this is it. Yeah. Oh, did you? No, yeah, I'm presenting right now, yeah. Pretty positive this is it. But there will be an option where you'll have to specify they'll have to specify MBA and also LLC, and I guess I could show you later, but I only have MBA turned on for this demo. All right, so any applicate or any VM task or any VM task or application running in the root is going to have 100% of the memory bandwidth. But so start the demo. I'm just going to have Redis installed on this system, and I'm just going and when you install Redis, it comes with the benchmark. So you can just get an idea of how fast Redis works on your machine. So, okay, yeah, you can pass them around, I guess, if they want to access. Or we just started, so if they want to follow along or go on their own. No, it's if you want to follow along with this demo and use a machine, yeah. Oh, up front, Keysong? There's one up front as well. All right. So first off, I'm going to get the GSAX. And I also made cores 0 through 8 isolated, so nothing's running on them. So I'm going to get the PID of Redis server. That is 1433. So I'm going to set it to core 0. And then run a Redis benchmark. So this is going to do, I believe that's in byte. Data size is 500,000 bytes. And it's going to do it 100,000 times. It's going to do a set and get, and it should print out some results at the end. So here we go. So when I run this, we'll see how fast it can run Redis benchmark set and get. And it's running on core 1. Let's see. I don't want for it to run too long. There we go. All right. So on an idle system, I'll have my set operation will be, what is that, 4,000, or yeah, 593 requests per second, and Git is 5,516, and that's for an idle system. So to show you NBA in action, I'm just going to run a bunch of stream processes, and it's a benchmark that really exercises the memory bandwidth, and there's some parameters that you can set, but I believe when you compile it, you can set environment settings, or you can just compile it with these settings. So if I cd into stream, and your system should have that if you're following along, and it should be compiled, there's a program called stream C, and I'm just going to run a bunch of them to stress the system. And let's see. There we go. And I'm going to run them on cores. It doesn't, I guess for this purpose, doesn't matter what cores you run them on. And just to make sure it's running, yeah, stream C, and I'm just going to run another one. Oops. Actually, I'm going to kill that. I need to run a certain core. That one exited. You see. Oh, all right. So that's right. All right, so I will. So if I remember right, it was, if you guys remember, it was 4,500 roughly and 5,200, but could run it again if you want. So I'm going to run the Redis benchmark again and see if it's they're both contending for memory bandwidth. It's running on core 1. So it looks like it's affecting the set operation more than it is the Git. So if that's what you're concerned about, let me kill these. So is it pkill stream C? All right, kill them. So, just gonna remember these numbers. So, let's see. It's a rough estimate, but I believe it was roughly 4,200. 500 minus 4,200 divided by 4,200. So about 15% decrease when when stream C is contending with Redis for the set. So to mitigate that for the NBA in action, so what I'll do is I'm going to cd to sysfs res control. All right. So I'm going to make a directory called low priority. It's going to be a different class of service, and anything that I deem as low priority for MBA, I'm going to put in this class of service. So cd into low priority, and it automatically, as you can see, makes these files and directories. So for the CPUs, I'm using CPUs instead of specifying the task or PIDs. I'm going to label CPUs 2 through 8 as low priority. So to do that, I am going to echo to the CPUs file. And it's just a bit mask. Let's see. Where are we? There we go. So let me cat CPUs. And a more human readable is if you read CPUs, as a CPUs list. Yeah, so 2 through 8, that automatically gets updated when you modify CPU's file. Uh-oh, I hope my computer doesn't. Does anybody have a Lenovo charger? All right. So we deemed CPUs 2 through 8 as low priority. So the next step is to actually say what low priority is. So we will go to the schemata file, and socket 0 in this low priority class of service has 100% of the memory bandwidth, and also socket 1 has, oh, thank you. There we go. And also socket 1. So for MBA, its resolution is in increments of 10. So it goes from the lowest you can set is 10% of the full memory bandwidth, and obviously this is set to 100. So I'm going to modify it to only, on socket 0, it's going to only have 10% of the memory bandwidth available, and same as socket 1, even though we're not going to run anything on socket 1. All right. So let me just double check. And cat CPUs list 2 through 8. Clear. And so this is where we'll want to make sure we pin our stream, our, if you want to call it noisy neighbor, or we deem it as a low priority workload, to pin it to CPUs 2 through 8. So let me go to stream. All right. All right. So the first one is going to be pin to core 2. All right, just double check. It's running. Next one is going to be pin to core 3. And last time I ran 3, and I'll run 3 this time. Stream processes. And 4. All right, so let me run the benchmark. And fingers crossed, it runs, at least the set runs near idle, or no, excuse me, when the system was idle. And something's not working right. So I believe it was 4,200. 1,000. Well, maybe it's getting there. Let's see. Clear. What's the, yeah, I guess I'd have to run it again to double check. It's not as good as I thought it was going to be. Previous times, I've gotten it, I would have to go back, but I believe running, not setting it to low priority, a decrease of 25%, and then setting the stream API became a decrease of both 10 to 15%. So that you're not going to get it absolutely back to when the system is idle. But I guess I would have to debug. But that is the gist of it for MBA. And there are tools. I believe Intel, the resource monitoring daemon. So you wouldn't have to do this manually. You wouldn't have to write to or mount the res control file and manipulate the files itself. It's just a command line utility, or actually it's a REST API, so you just feed it values and it'll do it for you. And I believe one of the goals, it's a reference design. I'm not sure if the creator is here in the audience, but I believe one of the goals is to look at the current workloads and adjust accordingly, so you wouldn't have to do it yourself.
Would I be able to get a summary what I really use versus what I have said?
A summary of what you really use versus, so if you go to sys or the sysfs res control, there are a couple of files. If you go to, monitor data.
With timing and all that.
What was that?
Is it just give timing, what time, table, what I use? Or
Kind of like a summary over time.
yeah.
No, there isn't anything. There's like a real time where it updates, like say every second, but there isn't what you're asking for, like say at 5 p.m. what your workload is of that day, and
What I
that,
really did versus what I said.
yeah.
How to have a ESDB client
I know, but it is available.
do you know if something like that's available?
We have some references
Okay. Is it, does the user have to, I assume they have to set it up themselves? Is there a reference design that someone can go implement and make a product out of it?
Okay, I'll pass.
All right. And then there was like I said, there was an Intel RMD tool, and then and I believe you have to build that from source. It's written in Go. And then if you have Ubuntu, a tool called pquas that you can install yourself. And if I'm not mistaken, I think you can't run the way I'm doing it is through reading the virtual file system and this tool called Intel CMT. You can't run them side by side. So you got to pick one or the other. But I believe this is going forward, correct me if I'm wrong, this is how they're going to do it going forward, right? Reading from the virtual file system, yeah. Okay. All right, that's it. Any questions? Yeah. To my knowledge, I'm pretty positive it comes on all Cascade-like CPUs. And yeah, with Broadwell, introduced the allocation of the LLC, and then they skipped over it on Skylake, and then the Cascade Lake, you're able to have granular control on the last level cache again, and also memory bandwidth. All right, that's it. Thank you.